Have you ever wondered what makes your favorite gadgets tick, or how industrial machines manage all those precise measurements? Well, a lot of the magic comes down to a tiny, unassuming component called the operational amplifier, or op-amp for short. Op-amps are like the Swiss Army knives of electronics. They're everywhere, quietly making sure signals are strong, clean, and ready to use, whether you're listening to music or monitoring a patient's heartbeat. Today, I want to take you behind the scenes to uncover the incredible versatility of op-amps. These little chips are the backbone of modern electronics and industry, handling everything from whisper-quiet microphone signals to the demanding requirements of industrial sensors. Without op-amps, our world would be a lot less connected and definitely a lot less fun. In this video, I'll walk you through 8 real-life and industrial applications where op-amps absolutely shine. Whether you're a student, a hobbyist, or just curious about how things work, you'll see why op-amps are the unsung heroes of electronics. And maybe you'll start spotting them everywhere, just like I do. Let's jump in. Imagine trying to listen to a friend whispering across a crowded room. It's nearly impossible, right? Well, a lot of the signals we deal with in electronics, like those from microphones, biomedical sensors, or temperature probes, are just as faint. Op-amps step in to amplify these weak signals, making them strong enough for controllers, displays, or other circuits to read and use. Think about your favorite podcast. The tiny sound waves from the host's voice are turned into electrical signals by a microphone, but without amplification, you'd never be able to hear them over your headphones. This isn't just for sound, though. In hospitals, op-amps boost the minuscule voltages from heart or brain sensors so doctors can monitor us accurately. In factories, temperature sensors need their signals amplified to control machines or sound alarms. Op-amps are the MVPs that make sure no important signal goes unnoticed, turning whispers into shouts so we can all understand what's going on. Sometimes, electronics need to make quick decisions, like, is this battery about to die, or has the temperature gone too high? That's where op-amps working as comparators come in. They compare 2 different voltage levels and instantly output a high or low signal, sort of like a referee blowing the whistle when something crosses the line. This function is super useful in battery level indicators, where the op-amp can trigger a light when your device needs recharging, or in overvoltage protection circuits that shut things down before damage occurs. Comparators are also the brains behind temperature limit detection in everything from ovens to industrial freezers. If the temperature drifts out of the safe zone, the comparator reacts right away, keeping things safe and efficient. It's like having a vigilant watchdog inside every smart device, always ready to act when something's not quite right. Have you ever noticed how your phone call sounds clear, even with all the electronic chaos happening around it? That's thanks in part to op-amps used in active filters. These filters help clean up signals by letting only certain frequencies through, like a bouncer at a club who only lets the VIPs inside. With op-amps, engineers can build low-pass, high-pass, and band-pass filters to shape and refine signals for communication systems or audio processing. Active filters powered by op-amps are everywhere, from your car's stereo system to noise reduction circuits in industrial environments. By filtering out unwanted frequencies, they ensure that what you hear, see, or measure is as crisp and accurate as possible. It's like giving your electronics a superpower for focus, helping them ignore the static and zero in on what matters most. Op-amps don't just amplify. They can also do math, which is honestly surprisingly handy in electronics. Integrator and differentiator circuits are built using op-amps to perform mathematical operations on signals. Integrators sum up input over time, turning a sharp step into a smooth ramp, while differentiators do the opposite, highlighting sudden changes. This is the magic behind analog computers, waveform generators, and even motion control systems for robots. In practical terms, integrators help create smooth control signals for motors, while differentiators can quickly detect changes in speed or direction. Whether you're designing a synthesizer or a factory robot, these op-amp circuits provide the mathematical muscle needed to shape and respond to dynamic signals in real time. Sometimes you need to look at a sensor's output without disturbing it. Kind of like reading someone's diary without leaving fingerprints. That's where the voltage follower, or buffer, comes in. Built with an op-amp, a voltage follower provides high input impedance and low output impedance, meaning it can listen to a signal without loading it down or altering it. This is critical when interfacing with sensitive sensors, analog to digital converters, or data acquisition systems. Buffers ensure that delicate signals reach their destination intact, whether that's a microcontroller in a weather station or a data logger in an industrial process. They're the strong, silent type, never changing the signal, just making sure it gets where it needs to go without interference. So, the next time your sensor data looks perfect, remember to thank the humble op-amp buffer working behind the scenes. In factories and plants, accurate measurement is everything. Whether it's pressure in a pipeline, temperature in a reactor, or flow in a water treatment plant. Op-amps are essential here, amplifying and conditioning signals from industrial sensors so that controllers can make smart decisions. Without this amplification, many sensor outputs would be too weak or noisy to be useful. These conditioned signals are then used to automate processes, control machinery, and ensure safety. Imagine a chemical plant relying on precise temperature readings to avoid dangerous reactions. Op-amps are the guardians making sure every measurement counts. They don't just amplify, they convert, filter, and clean up signals so that the rest of the system can do its job reliably. In other words, op-amps are the quiet custodians keeping industry running smoothly. When it comes to controlling big, powerful machines, precision is key. Op-amps play a huge role in power electronics, helping regulate motor speeds, provide feedback in inverters, and ensure stable operation in switch-mode power supplies. They monitor voltages and currents, compare them to set points, and generate control signals that keep everything running efficiently and safely. In motor speed controllers, op-amps process feedback from sensors to adjust the power delivered to the motor, allowing for smooth acceleration and deceleration. In inverters and switch-mode power supplies, they keep output voltages steady, even when loads change. And in protection circuits, op-amps react instantly to abnormal conditions, shutting things down before damage can occur. They're like the brains behind the brawn, making sure power systems are both strong and smart. Nowhere is the reliability of op-amps more critical than in medical equipment. Devices like ECGs, EEGs, and blood pressure monitors rely on op-amps to amplify the tiniest bioelectric signals from our bodies. Signals so faint they disappear in the noise without help. These signals are then processed, displayed, or even stored for diagnosis, all thanks to the precision and sensitivity of op-amp circuits. Op-amps are also at the heart of medical imaging systems, ensuring that every detail is captured for doctors to interpret. From hospital bedsides to advanced imaging labs, these little chips help save lives by turning invisible signals into actionable information. When you see a heartbeat spike on a monitor, remember, there's a hard-working op-amp making sure that signal is loud, clear, and reliable. So, next time you pick up a phone, walk through a factory, or visit a hospital, take a moment to appreciate the humble op-amp. These tiny chips are working tirelessly behind the scenes, amplifying signals, filtering out noise, and making sure our devices respond just the way we expect them to. They're not flashy, but without them, so much of our modern world just wouldn't work. From signal amplification and voltage comparison to active filtering and mathematical operations, op-amps are central to electronics, industry, power systems, communications, and medical equipment. Their ability to condition, process, and protect signals keeps everything running smoothly, whether it's controlling a robot arm, maintaining a power supply, or monitoring a patient's vital signs. Op-amps might not get the spotlight, but they're true unsung heroes. As you explore more of the electronics world, you'll start to see them everywhere, quietly making our technology smarter, safer, and more reliable, one signal at a time.